Hello, my name is Brett Golder and I will be going over the impaired water body water quality monitoring, control, and redemption measures for Tinker Creek. Tinker Creek is located in the vicinity of Roanoke, Virginia, and it will be covering the entire main stem from the headwaters downstream to the confluence with the Roanoke River. It is a state water body type of a river. It is 19.33 miles long, and it is in the Tinker Creek watershed. As far as an introduction to the water system, Tinker Creek is a 19.33 mile stream in the Botetourt County, Roanoke County, and Roanoke City, Virginia. It has a designated use of recreation. It is also classified as an impaired water body on the 2016 EPA 303D list for E. coli. 11.87 miles of it were formerly designated with a temperature impairment that has since been removed. There are also known sources for the E. coli impairment, including agricultural production, storm sewer discharge, sanitary sewer and septic tank overflows, direct inputs from livestock, runoff from municipal areas, including pet waste, and direct inputs from wildlife. A TMDL has also been completed in 2004 for this water body. As far as the water quality monitoring protocol, first of all, the optimal site conditions should be followed of 2 sites to represent each potential source of contamination, 1 site upstream of any contamination source, which would be near the headwaters in this case, full documentation, photography, and site evaluation, including noting soil type, vegetation, land use, etc. You should potentially target surrounding land uses of high agriculture production, areas of moderate to heavy urbanization, and forested natural sites. Tests should be done seasonally, making sure to test during base flow and stormwater conditions. A seasonal test will have water sampled every 6 hours over a 10-day span. You should also find a corresponding unimpaired reference site within the general region of the watershed. The following satellite images show potential sites for monitoring along the Tinker Creek water body. The first is an area of agricultural development upstream within the watershed that would allow for a good quantification of the agricultural impact on the system. The next area is an area of forested impact that would show a good input of the natural sources on E. coli concentration. Next would be an area of urban impact included within Roanoke City proper. This would show a heavy amount of urbanization input into the water. These sites can be seen through the blue, green, and black dots, blue being agricultural, green being forest, and the black being the urban spot. Other potential spots to find these would be more farmland upstream of it, other forest lands near the Carvin's Cove area, and areas of urbanization such as Daleville and Hollins along Tinker Creek. Remember, a secondary reference site should also be made somewhere within the same watershed at an unimpaired stream. Next, we will go over a basic description and steps of the monitoring protocol. First of all, the preparation and sampling should follow EPA method 9060A. The preparation should include samples collected in plastic bottles that are rinsed in deionized water. These bottles should be treated with a dechlorinating agent to slow microbial growth so that the colonies can be accurately quantified. The bottle should be sterilized through dry heat. For sampling, some airspace should be left in the bottle for mixing. Samples should be a true representation of the water sampled and should be taken near the center of the creek. Samples should be taken from a boat or bridge in more sensitive areas, and if there is a nearby tributary, it should be taken at the confluence of the 2 streams. Once the samples have been gathered, they should then be stored properly. They should be stored in leak-proof sterilized polypropylene containers. They should be placed in a cooler with ice at 1 to 4 degrees centigrade. They shouldn't be inundated with water. Samples should not go more than 3 hours before analysis. Analysis should be completed within 8 hours of sampling. For sample analysis, the EPA method should follow 1604, and all equipment should be sterilized beforehand. The procedure for this method involves a 100 milliliter sample being sent through a membrane to be filtered. The bacteria that is collected in the membrane should then be incubated for 24 hours in a plate with broth. Colonies should then be inundated with UV radiation at 366 nanometers for fluorescence. These broken down enzymes can then be counted to get the amount of colony forming units within the 100 milliliter sample. All potentially infectious wastage should then be autoclaved and disposed of. Next, I will cover the assessed risks of E. coli contamination. E. coli is not a major threat on its own, as most strains are not harmful to human or animal health. E. coli serves as an indicator for the amount of fecal waste in a water body. A high concentration of E. coli indicates a high concentration of fecal matter in the water. This high concentration has an elevated potential to contain disease-causing pathogens. These pathogens can result in illness to humans that swim in or drink the contaminated water. Next, we will go over the water quality control and redemption process for this system. The figure shows the amount of the existing load that needs to be reduced in order to meet the 100 CFU per 235 milliliter cutoff for E. coli contamination. These changes can be achieved through improvement of urban facilities, better agricultural regulations and management, and educational programs. To do this, we need to cut down development by 98.7%. We need to cut down agricultural inputs by 99.8%. Forest inputs need to be removed by 95%. Wetland inputs need to be removed by 95%. Others need to go in by 98%. Direct inputs of livestock need to be removed of 100%. Direct inputs of wildlife should be reduced by 74.9%. Failed septic systems, pipes, and sewer overflow should be taken down by 100%, and there is no point source. In total, it should be reduced by 99.2% in order to reach the achieved goal. Next, I will go over the TMDL implementation for the urban sources. There are many ways to reduce the urban-based sources. The first would be the creation of more PET waste disposal systems, which would cause a reduction of waste runoff into the water body. Next would be the development of more efficient stormwater control systems, which would reduce the amount of wastewater and E. coli entering the water body. Next would be the construction of waste storage facilities such as detention basins and retention ponds, which would store the wastewater and reduce the amount of it that flows into the water body. Next, you can repair or replace damaged or inefficient septic and sewer systems, which would lead to the elimination of unintended wastewater leakage or overflow. Next would be the TMDL implementation of the agricultural and natural sources. The ways to reduce these sources would be first to implement a rule that excludes livestock from the water body, which would result in the elimination of direct waste from the livestock. Next would be to construct fencing along open fields, which would prevent accidental livestock waste input and prevent some wildlife waste from entering. You can also work with farmers to negotiate nutrient plans, which will give you the ability to know and influence how much manure is applied and how much potential runoff can be quantified. You also should encourage and educate farmers of sustainable farming practices such as no-till, cover crops, and crop residues. This will cause a reduction of runoff from any fields that have manure applied. The next would be a creation of a riparian buffer area along the water body. This would stop the reduction of general contamination via runoff from all sources. The last stage of the TMDL implementation is through the education of the general public. The public should be engaged in this project through town hall meetings, flyers, representatives at public events such as festivals and local gatherings, and volunteer opportunities with local organizations to implement some of the TMDL, such as planting a riparian buffer. These can include the Clean Valley Council, Roanoke Greenways, or other potential volunteer organizations in the area of the watershed. And finally, here are the sources. Again, I've been Brett Golder, and this concludes the Impaired Water Body Water Quality Monitoring, Control, and Redemption Measures for Tinker Creek